All right, so continuing with chapter 4, 4.3 histograms. A lot of this is going to look familiar because a lot of this ties into stuff we did with dot plots as well. And corresponding readings will be pages 46 to 48. So a couple things we've done so far. We've done frequency tables, relative frequency tables where we have percents, bar graphs or charts, pie charts, and now we have histograms. So quantitative variables often take many values, and then a graph of the distribution is clear if we group those values together. The most common graph of this distribution of quantitative variable is A. All right, so our most common graph we'll use a lot is a histogram. Now, to make a histogram, you're going to divide the range of data into groups of equal width. These are also referred to as bins. And then we're going to count frequencies or percent if we're doing with relative frequency of individual groups. And then we're going to label and scale our axis and draw our histogram. We'll talk about that. We'll do some by hand, and then we'll actually learn how to do this with some technology as well. All right, so in histogram, an example here, gives us a bunch of things. Distribution of quantitative variable separated into bins. Each bin counts as a bar. Gives the building blocks for a picture. We can do frequency or relative and have no gaps between bars. Occasionally you will if there's no data within that bin. And then bars show all values of the variable. All right, so making one here. So I want you guys to try out and see if you can't make a histogram based on this frequency table. The bins, the range is already kind of set up for you with the count as well. All right, so here's an example of what that histogram would look like. You can see the 0 to 5 is our 20, right? And so that's the 0 to 5 range. Then 5 to 10 is at 13, and so on from there. And then notice that there are no gaps where one starts, the other one ends. And we'll talk about what happens, hey, if there's one that landed on 5, 10, or 15, how that is handled. So here is one where it's a frequency table. Notice it's just numbers on the sides. This one, the bins are a little bit smaller. They're every 2.5 as opposed to 5. That's why the data looks a little different. So nice example of how things look different based on how you adjust your width of each bar or your bin. Here's one with percents now. Okay, and so again, they split it up. Notice how you're like, well, 0 to 5 says 40. But we don't have 40, it only goes up to 30. Well, that's because they split it up as, again, at the 2.5. So total, if you add those two things up, there's 10 and there's 30, so that's our 40 for that. So looking through just some basic stuff, this bar has a height of 13. And that's where we got it from. And this is between 5.0 and 9.9, and actually goes 9.99999, does not include 10. 10 always goes, the number always goes to the right of the number, so it goes with that bar. Okay, so another example here, same idea. All right, so as we look at this, we have 9 bins with width of 20. And then you can change those bin widths, and so it definitely changes how the data looks. We still look very unimodal, very fairly symmetrical, but I think there's some more information Then the last one, 5 bins of width of 40, I think there's too few. You know, as we look at this one here, I think it's important to see that little dip, and then we come back up, where this one just looks like it drops off precipitously. And then here, there's a lot more data in that section where it's just like, oh, it looks like one, and then a big jump, which kind of fits there. And so there's definitely a little more data as we look at that. So that is some of the decisions, because you get to choose how big you want the width of your bin. And so how you choose that can definitely impact what your histogram looks like. All right, so here we have some things where we talk about center, spread, and shape. So we can find our mean, our median, talk about this. So this is still, we have the skew, just like we talked about with dot plots. We still have our unimodal. And so there's different things that we can figure out within this. And we'll go into this a little bit more detail later. All right, so go and answer this. So what mode is this histogram? And then what mode is this histogram? And again, what mode is this histogram? And our last one, what mode is this histogram? So we talked about those with dot plots. You have the bimodal or multimodal, which we saw both of those. We have unimodal, and then we have uniform. So we saw all 4 of those in the previous problems. Okay, so those were true in dot plots. They're also true in histograms. Just like dot plots, we also have ones that are symmetric. We have skew, whether it's right skew or left skew. Those all still and rules apply exactly the same. So here's some examples: a left skew, a symmetrical, and then a right skewed. And notice on, again, the skew, how that tail is going to the left. This one, it's a right skewed because that tail is going to the right. Just like with dot plots, there can be gaps, there can be outliers. Right, so we got to pay attention to those, and within that, as we get into more of the details of center and spread and all that, of mean, median, mode, how that all affects that information. So measures of location. So we have mean, and that's really good when we have symmetrical data. Median is better when we have skewed data. That's why it's called skewed right, because for a mean, some very small values, but really far out there to the right or the left skews that mean quite a bit. And then mode just isn't always the best indicator of data. And we talked about that when we talked about the 3 M's a little while ago. And then just a little caution, don't confuse histograms and bar graphs. So a histogram has data, and you notice that there's no real break unless there's no data at all, where our bar chart has all these, because there's not this continuous collection of data. All right, bar graphs, bar charts are more about categorical, and you're just listing how many fell into that category, where histogram is now quantitative, and you have this stream and flow of data across a continuous number.